You hear me?
Yes, I can hear you. How are you doing today?
Okay, I am fine. How are you?
Doing well. Making some progress. Looks like you went to a fun ag show over there.
Is no one will join us in this meeting?
Well, I think I ran into some technical difficulties when I started the meeting. For some reason, it wasn't synced up right. But so they may have tried earlier, but it's about 15 minutes now.
Okay. I will discuss some points with you. Okay?
Okay.
The first point about the control and the GPS input. How to deal with it. And Jeff was talking about something called GEO Fence. Okay?
Yep.
Give me more details about this.
Okay, so basically a GEO fence is basically just an area where if your robot tries to leave that area, it will shut down. So you have sort of like a shape, and then the node will test what your GPS location says it is compared to this area that's a safe operating zone. And if you're not in that safe operating zone, then you can take actions, shut your vehicle down.
How to obtain this area?
How to what?
Obtain.
Well, you need to tell the robot what the safe operating area is. You know, kind of like a polygon.
What is the tools used for this?
Well, here's an example of it, GEO Fence written in Python. And so basically this script, this is a node that's already written. And you just tell it what is the GPS, what's the bounding area of your GPS zone. And then this node will take your GPS location, compare it to you to see if it's in the area. And if it's in the safe operating area, then it'll let you run. If it's not in the safe operating area, then you can start your shutdown procedure.
Okay. For any field, this is written by code, or it may be scanned using any other tool.
You may scan, but you need to have geo-referenced areas. This uses GPS lat long location. You can do the same thing with local coordinates based on your map.
Your internet connection is not stable.
Yeah, I know. It bounces in and out.
Okay. Can you give me more details and hands-on experience about the GPS RTK?
Yeah, sure.
Other than video
GPS.
Other than this video from the Granite Academy.
Fro. I didn't get to that last part about Frobo or something. Are you looking for an RTK GPS?
Yes.
Yep, it's the same story. Nothing's really changed. That U-Blocks is the lowest cost GPS on the market. And so it just depends on what is your accuracy, what is the necessary tolerance that you want to hold, and how much money you have.
Okay. How to deal it in the control of the robot.
How to deal with it?
Yes.
How do you use your GPS location?
As an input of the field that the robot is working in.
Yeah. So if you're talking about, are you talking about the robot, the rover itself, or are you talking about mapping a field?
I am asking you to tell me
How GPSs work in ROS?
I mean how to take an input from a farm or a field and control the robot based on this input.
Yeah, maybe a couple pieces missing. So what's the use case? What are you trying to solve?
Can I share the specs of the dot robot with you?
Yes.
Okay. You see,
Yes. Yeah, dot.
can you read this with me?
Yep. Yep. So it's generating a path based on the parameter of the field. So the perimeter of the field, sorry. So it takes the perimeter of the field, and then this one will automatically generate paths for your robot to drive down. So that's
This what
done
I
with a planning algorithm.
how to achieve something like this.
You can build it yourself, or you can look at AutoMo from Auburn, University of Auburn.
What?
There's a school called University of Auburn, and they have a project called AutoMower.
Send me the link, please.
And they also have a planner. So if you're talking about being able to input a field shape and then have it plan the area, here's a video. That's a video of the lawnmower. And then
Okay.
and then this is their GitHub account. So if you are looking for how do you determine where you want the robot to run, here's another video of their lawnmower with path planning.
Why all people starting with lawnmower, not go in deep agricultural process such as harvesting or weeding or any agricultural process that is critical to farming?
It's a good question. I'm not sure. Getting a base platform moving around is kind of what people are working on.
You are starting with lawnmowers, not to get in deep agricultural process.
Well, this is a learning tool to allow people to learn how to automate a vehicle.
I am here in Egypt, started thinking in the same way from 2 years ago. I don't know how this can can be there.
So this last link I sent in there is the planning algorithm they have that will plan the path for the robot.
Okay.
So these are big topics in planning. There's some other algorithms out there that do path planning. If you take a look at the meeting either last time or on Tuesday night, Ezra, she's a planner and she demonstrated her planning algorithm.
She is working in, I searched about her Here working in Danfoss, I think.
Yeah, exactly.
Yes. You are sharing these links on the general Slack after the end of the meeting, yes?
Yes.
Okay. How much time do you expect this process will take?
Couple years.
Couple years?
These
Too
are
much.
too much. Well, you could probably get it. I've got Auburn's planner. I have that working, so that one maybe only take you a week to get that installed and test it out.
I don't understand.
So you there's a you're looking. Are you familiar with planning, path planning with robots?
No.
Okay. Well, I'll write that term down. Planning, path planning.
Yes.
Yep. That's what you're asking about. How do you plan a path around a field? There's a couple of ways to do that. The example with the auto mow on Auburn is it will generate the path for you. So you have a polygon shape inside of RViz, and then it will draw the lines in there for you. What other people, or another approach, is basically train and repeat. So you record where you want the robot to go, and then you just play back that path. And there's a class from the Robot Ignite Academy that teaches you how to store those waypoints as your robot's driving around, and then how to play those back. And that's
Yes.
in the Lawn Tractor channel.
Yes.
There's two classes from the Construct that Ricardo put together for us. There's an outdoor navigation 1 and 2. So that's a great example of recording waypoints, playing waypoints back. Or a robot, you can use their simulated environment, and then you can test and see how the GPS goes into ROS and how you drive it around. And that's all done in simulation.
All this bus planning is mixed with GEO Fence.
So the GEO Fence node isn't there, but I sent you the link to that node, so you can start that node up. That's just a listener node, so it's just listening to your GPS coordinates and comparing it to where the robot's supposed to be.
Okay. I have worked before on bus following on the Coursera course, but planning was not included in this course.
Yeah, it can be tricky. Planning can be tricky.
Yes. Can you give me a general view about the control of the robot?
What's that mean?
General overview about the control of the robot.
ROS Control. You can look up ROS Control, and there's on the wiki, there's a good explanation of what ROS Control does, how that functions. And there are also really good videos from the Construct. That you can use to learn about ROS Control. Have you been watching any of the videos on YouTube from the Construct?
Yes. I have watched the one about GPS before, from a long time.
Okay. That's a good place. They have a lot of videos. They have weekly live classes that you can take for free on YouTube. And then they also have a lot of good tutorials and videos and answering questions. So it's a great resource.
Okay. I have asked Sean about the more critical issues in the field of agricultural robotics. He told me about safety, reliability, and making robots easy to use. All these subjects are critical. Let's discuss in them.
Okay.
Starting with safety, how to achieve safety.
How do you achieve robot safety?
I am adding in the smallest scale I have worked before. I am adding small limit switches that any sensors that if detected anything, the robot is shut down. But in this is in a small scale.
Yep. So have you found any papers on robot safety or any standards that you're following?
Until now, no.
Do you have an emergency stop on your vehicle or your robot?
Yes.
And then do you have like a safety checklist of the operating area you're going to be running in? And then a checklist for your robot before you take it out and run?
What are the components of this checklist?
Yeah, safety is a big issue when running robots, and there's not a real quick and easy answer.
The main elements to achieve safety.
A safe robot that has redundant safety systems built on there, ways to detect obstacles in front of the vehicle or around the vehicle. Number one is getting your vehicle safe, and then number two is getting a safe area to run your robot.
Until now, no standards or legal issues for the safety of robots.
There are a few. Here's some. I post ISO standards for robotic safety. Posted that into general. I can add. There are a few standards. There's a standard in agriculture called highly automated agriculture machines. It's a draft right now, but it has some good points.
Okay. For the point to make robots easy to use for farmers or any user who will be using it, how do you think we are able to achieve this?
There's different standards for measurements, like there's one called mean time between failure. And so you want to know how long you can run your robot before something happens and it doesn't work. And then there's mean time to fix. If something does happen, how long does it take you to get it running again? So part of usability is having a robust platform.
I have read in the robot, in the .robot paper, that they have built a tablet-based human HMI, human machine interface.
Yes.
Something like this. How can I build a prototype like this?
What do you have an example of their control station or their user interface?
They are using Wi-Fi and this tablet-based HMI to control the robot.
Yep.
Something like this. How to start to build something like this?
Are you familiar with any other ground control stations or any
Like
other like drone deploy or Q ground control or mission planner?
No.
So it just depends on your application and what you're doing, but everybody has to have a ground control station. Obviously, you have to have some way to interface a human-machine interface into your robot. And then it just depends on if you want to build one from scratch, if you want to build one via the web. There's a robot web tools where you can use, I think it's JavaScript to interface with ROS and control your robot.
Something like this achieve the function that the robots will be easy to use.
That's the game right now. It's hard to use robots. We're trying to make it easier, but they're still very difficult. That's a big issue, especially with farming. Different languages, so need to have some sort of interface that will work.
How should we work as a ROS agriculture community to achieve this?
There's been some discussions around that, and it could be more task-based. If you want a full ground control station, then there are some examples already out there that people are using for drones that also run. You can use them with ROS.
Okay, but for ground vehicles?
Yep, it's pretty much the same. You just have different constraints and different maps, and if you're outdoor, then you're using GPS. I mean, there's a different setup depending on what type of robot you're using and what you want it to do.
Yeah, to summarize this point, to achieve the easy of use for robots.
Yeah.
What are the main points?
The main points is just all of the principles of user interface design. So make sure you understand those principles of user interface design, and then make it for whatever task. For example, if you have a weeding robot and that weeding robot goes up and down the field in the same way, the farmer just wants to put it into row 1, push a button, and then the robot goes up and down the rows, and when it gets to the end, it stops. What would be the easy user interface for a robot like that?
A tablet-based interface.
Yeah, tablet-based interface. Exactly. Yep.
Can we achieve something like this to be an open source?
Yeah. Mm-hmm. There's already some examples of open source Android applications, and ROS will run on Android, but if you just want the control station, that issue isn't solved yet. So you have some opportunity to work in that area.
Okay. This discussion this week is critical.
Yeah.
The third point is to make robots achieve reliability.
Yes, that's the mean time between failure, mean time to fix, whatever standards you want to use on your robot. You need to take your robot out and drive it around for a few thousand hours and see what happens. Can it last? Do what?
Just by experiment? No measurements?
Yeah, like if you got your robot out working in the field, how long could you run it before something happened and it broke? 500 hours? 1,000 hours? 5,000 hours? Okay. 2 hours? You know?
1 minute?
1 minute? Yeah. That's the way it starts out. You know, you can get a little bit farther, a little bit farther, a little bit farther. Those are big issues. Each one of those. Robot safety is a huge issue. Robot reliability is a huge issue, and robot interface, HMI, is a huge issue. So those three topics are those are entire fields of study.
Okay. You are. I am asking you to make the general Slack working with these critical subjects.
Yeah.
From week, no one is discussing anything.
Well, if you post in there, we could start a conversation, and then we'll start posting links, and we can learn.
Okay.
You can help out in that area.
Okay. There exists two points to end the discussion. The first point, how saving power and making robots efficient.
What was the first question about saving something?
Saving power and making robots efficient.
Oh yeah, low power use.
Yes.
And then what's efficient mean?
Efficient is doing the same thing with less power.
Less power. I don't know. That's electrical engineer. I mean, that's another big issue. Power consumption, low power components. How do you make that? I don't know.
I will tell you a small story. I have met in the Sahara Desert, Sahara Fair. I have sent the photos to you. Okay.
I like that. Yeah, that's cool.
There was a sprayer, nearly 3,000 tank, 3,000 liter tank. Okay. The tractor which will be pulling it needs power nearly 150 horsepower. Okay.
Yep.
I have searched for the dot robot. The last video I have posted in the general Slack. The robot tank of the sprayer was nearly 6,000 liters. Okay.
Yeah. Twice as big.
The power of the generator on the dot robot nearly the same 160 horsepower. Only 10 horsepower difference, but double the difference in the capacity of the tank. For this, I am asking this question. Have you?
What's the question? Have I what?
Have you understand what I have said now?
You said at the Sahara Farm Show you saw a sprayer that had 3,000 liters with a 150 horsepower engine, and then DOT is 6,000 liters with a 160 horsepower engine.
Yes. How something like this is achieved?
Well, how is it achieved? I don't know. That's maybe mechanical engineer, but like, what's the? I don't know.
This is what I mean with efficiency. Using the same power to making things bigger than, or doing the same thing with less power.
Yeah. Yeah.
This is a critical topic to achieve this.
Are you going to be running all electric?
Yes.
Okay. Yeah, big issue. I don't know. That may be a good discussion to post up there to see what people think. I don't have experience with that.
I have prepared these topics all last the week.
Are you? I mean, what's the question? You want to know how big to size your robot motor? I mean, with electric engine, you're not. I mean, it just depends. There's so many factors. Like if you're spraying in the trees, then you need to throw water 50 feet. The size of the engine is going to be like 400 horsepower. even
No,
though the tank is only like 600 gallons. If you're doing an herbicide spray and you only need like a foot little band, then, you know, a little 12-volt sprayer will work. So really depends on your use case, and then how are you going to tailor it to that. Dot is a little bit different.
both sprayers I have seen were boom sprayers, the same sprayer in the design.
Yeah, Dot is a little bit different in the sense that the base engine, there's different attachments that go on top. So it's not built specifically just for spraying.
Yes.
It will do other things. And so if you're going to build a robot that's specifically for boom spraying, then are you going to have all of the jets on at once, or are you going to be have a vision system that's only going to spray one here, one there, one there? And then how big is your boom? Is it 120 feet, or is it 8 feet, 4 feet, you know, or meters, whatever, you know, 30 or 40 meters? Is it 40 meters or is it 2 meters?
The other meeting, the other ROS community meeting will be at which time for me?
3 a.m.
3 a.m.?
Yeah.
I will try to join you.
You can get up. We
Okay.
we have another person that gets up at 3 a.m. Or we can get some people from Europe into this meeting. I haven't advertised this meeting so much out in the ROS community, but if there are other people that are interested, we could build one specifically. So like your 15 horsepower, 17 horsepower tractor, that looks pretty cool, right? But out in these large fields where you have thousands and thousands of acres, you know, they're running large tractors. So different use cases for different areas.
You have worked before on ASI for
Yes.
making large tractors autonomous?
Yes. I worked in orchards and vineyards, so I primarily worked with smaller tractors, 95 to 115 horsepower. The largest tractor I worked on is a 600-gallon spray tank with 450 horsepower engine.
How complicated was this?
Easy.
Easy?
Yeah, but that's all it did. It was just a sprayer. It wasn't multi-function machine, you know. And I only had one task, drive up and down orchard rows. So if you narrow the scope, then your machine gets simpler because it's only doing one thing.
Okay. The last point, the steering design.
Yes, big. So that tractor.
That tractor.
Yeah. Yeah, so he has assisted power steering, which is probably, I don't know for sure, but it could be that electric power steering, which is great because you can tie into that. It has a shifter, which it's difficult to shift in a pattern to make that work. And then the other thing is braking. How are you going to apply brakes? So steering and braking and throttle. This one had the throttle lever on the dash, which you could put an actuator on that. But how are you going to control the machine? What type of components?
I will using industrial PC with motor drivers, but until now the range of the power to determine which drivers to use is not determined.
Okay.
And the motors, this topic was critical the last meeting, but
yeah.
Until now we are studying to choose between AC or DC.
Okay.
Let's wrap up what we have talked in this meeting.
Okay. Overview. Do what?
Wrap up.
Okay. Yep. Do you have any other questions? Or so we talked about the human-machine interface. What are you going to do for your controller? I think using a tablet or a cell phone is good. A lot of people have those. Makes it easy. We talked about robot safety. I posted some links about that. That's a big topic, and we need to continue to have those conversations as a group so we can flush those out. And
Okay.
power constraints, may need to find an electrical engineer or start posting questions about how to do that part.
Okay. Some last point I have forgotten to ask you the communication in the rural areas, how to be achieved.
Yep. So if you don't have an infrastructure like cell phones or other things, then you just put a radio.
Nothing.
Yep. You use a radio from your robot to your base station.
RF?
Yeah.
Yep. Okay. Thank you very much for
You
your
bet.
time.
All right. We'll see you. We'll see you this morning at 3 a.m.
I will try. I will ask only for the GPS again and take more details about it.
Okay.
If you decide to take some points from these points we have discussed and discuss them, this will be grateful.
Okay.
Thank you very much again.
You bet.
See you 3 a.m.
Okay.
Okay, inshallah.
Ciao.